Welcome to the Windows Phone 7 application architecture. My name is Bill Loden, and in the next few minutes I'm going to introduce you to the basics of Windows Phone 7's new architecture. Now, here's a high-level view of the Windows Phone 7 platform. During this session, I'll be talking about each component that you see here. Now, we'll work our way up from the bottom, so of course that means I'm going to start with the hardware itself. The hardware is an important part of the architecture because it provides the foundation for everything else. It determines what features your application code has access to. For Windows Phone 7, Microsoft is requiring that phone manufacturers adhere to a set of minimum criteria. Now, these criteria are fairly demanding, meaning that all Windows phones will be up to the task of providing a great user experience. If you're a developer, you can count on the fact that your application will have access to a capacitive touchscreen with at least 4 contact points, an accelerometer, GPS, compass, light and proximity sensors, and a camera with at least 5 megapixels and a flash. You'll know that your code will be running on at least an ARM v7 processor, and that there will be a minimum of 256 megabytes of RAM. You won't have to limit yourself to a minimal least common denominator because all Windows phones will be highly capable. Now, let's move from the hardware side of the platform to the software, starting with the kernel. Windows Phone 7 features a modern operating system with support for virtual memory and paging. The OS also has built-in networking and security support, which is exposed via various APIs to the upper tiers of the architecture. In previous Windows mobile platforms, the OEMs were responsible for writing the device drivers. Well, in Windows Phone 7, Microsoft themselves are writing most of the device drivers, which makes for a more consistent platform and reduces the effort required of manufacturers. In most cases, a manufacturer will only have to write the very silicon-specific portions of drivers. Let's move on to the application model, and we'll start by looking at how applications are packaged. In Windows Phone, an application is a uniquely identifiable, licensable, and serviceable software product, packaged as a ZAP file. The ZAP file format was originally introduced by Microsoft to deliver Silverlight 2 applications. It's really just a zip file which contains the application's compressed assemblies and resources. Now, once you've built the Windows Phone application, how do you get it to users? The first step is to get it into the Windows Phone Marketplace, and this is a 3-step process. First, you upload the application to Microsoft. Next, Microsoft performs basic security checks as part of a certification process. Finally, as long as these various checks are satisfied, Microsoft signs the application and it's published in the marketplace. The application gets a crypto-verifiable license, which is used to grant rights to the application. Now, at this point, your users can simply download the signed ZAP to their phone, where it gets deployed. Once on the phone, your application will be subject to fairly strict controls to ensure that the user remains in control and that his or her privacy is never compromised. First and foremost, the application cannot make arbitrary changes to the phone during the installation process. To perform an install, the phone reads application metadata, which is declared in the ZAP file. Now, because it's declarative, the phone can easily determine whether to allow certain operations based on the rights granted by the license. After an application is installed, a user remains complete control over updates and can easily uninstall the application at any time. Now, because of the high degree of control which surrounds the installation process, an application can be removed without leaving any trace of itself. The Windows Phone operating system runs each application in complete isolation. Each app is sandboxed into its own separate security account to prevent it from being able to access another application's data and to prevent it from executing code that might compromise the operating system itself. The architecture also allows the resource allocation policy to make priority decisions. For instance, the foreground application will always be given higher priority to ensure that it remains responsive to user input. Now, each application executes inside an isolated, least privileged host process. This, combined with the fact that all application code is transparent and CLS verifiable, means that most common attack vectors are mitigated right out of the box. Now, the UI model is obviously the most visible aspect of the new Windows Phone platform, and to understand it better, we need some new definitions for some familiar terms. Now, earlier, I described what an application is in terms of the packaging model, In terms of the UI model, an application is user interface components plus logic exposed through one or more pages. A page is a single screen made up of UI elements. A session is an ordered workflow of user interactions, and in the Windows Phone UI model, it can span multiple applications. Now, the terms page and session might remind you of how web applications work, and it's no accident. Navigation in Windows Phone is not at all unlike browsing the web. There's even a back button on the physical device itself. As a developer, you can think of building an application as building a set of pages, and the great thing about pages is that they fit very well into a modular architecture. If you want to expand the functionality of an application, you can usually do so simply by adding additional pages. Now, next is Windows Phone support for cloud-based services. Integrating cloud-based services can add a lot to your application because, unlike a mobile device, the cloud is always on and has virtually limitless capacity and scalability. Now, there are three approaches you can take, and of course, you can mix and match. First, Microsoft has pre-existing services such as Bing, Search and Maps, and Windows Live ID, and you can leverage these from your Windows Phone application. Microsoft has also built two phone-specific services for location and for push notifications. Now, next, you can use the standard web service client stack from your application to access existing third-party services. For instance, you can access Facebook or Twitter directly from your application. Finally, you can build your own services and expose them on the cloud and connect to them as easily as in any other .NET client application. At the top of the stack, you'll find the application runtime, where your application will live. When you create a new Windows Phone application, your first decision is which framework to use. The first option is Microsoft Silverlight. It's a modern, event-driven UI framework that makes it easy to create great-looking applications that feature high-fidelity graphics, media, and animation. Most tools, utilities, and line-of-business applications are likely to use Silverlight. The second option is Microsoft XNA. Like Silverlight, it's managed code, but it's designed as a high-performance game framework. It supports both 2D and 3D games and provides a rich content pipeline. Windows Phone games built using XNA can be easily ported to Xbox 360, Windows Desktop, or even Zune. Whichever choice you make, you'll be writing managed code, and therefore the two frameworks can share a common set of platform components. Your app will run in the .NET CLR, and will have access to a large portion of the .NET Framework APIs, as well as phone-specific APIs such as sensors, location, telephony, and notifications. What's more, because of the .NET Foundation, you will likely be able to move your Windows Phone application to Xbox 360 or the Windows Desktop quite easily. Now, there's lots more to the application runtime, which I'll dive into a little deeper in upcoming 7 in 7 videos. For now, thanks for taking the time to learn about the Windows Phone application architecture.